Hello and welcome back to Arduino. In this video, I'll show how to interface ultrasonic distance sensor with Arduino. So let us go to Dr.K. Click on Arduino. Now select ultrasonic distance sensor. As you all know, ultrasonic distance sensor is used to measure the distance to an object using ultrasonic waves. It has VCC, ground, trigger, and echo pins. So for a new distance measure, we have to set this trigger pin to high for few milliseconds and wait until the echo pin goes high. And the length of the echo is always proportional to distance. And here the echo will give it in the microseconds. We have to convert into centimeters or inches. Per centimeters, divide pulse microseconds with 58, and to convert it into inches, divide with 148. So let us see how first we'll go with the connection part and then we'll write the program. So connect the VCC to plus 5 volts supply. Then ground to ground. And then the trigger pin, because it should go high, connect the trigger pin to 3 of Arduino. And then echo to 2 of Arduino. So the connection part is completed now. So serial dot begin, see for the serial communication, whatever you want. Begin with a baud rate of 9600 and set pin mode 3 as an output pin. And then pin mode 2 as input pin. Now, coming to the programming section. So digital write 3 to high, make it as high. So we'll wait for a few milliseconds. For that delay microseconds, you can use some delay of 20 microseconds. And then again, we can make the pin as digital write, 3 as low. Now read the pulse from pin 2. So int x is equal to pulse in. So read the pulse 2 as high. So once you read the microseconds, then what we have to do is we have to print the distance. So for that we have to go with the serial dot print ln distance in centimeters. For centimeters, I told you, you have to divide the pulse with the 58. So serial dot print the x value with the 58 to convert pulse seconds, microseconds to centimeters. Similarly, you can take this. So serial dot is inches, and we for that we are divided with 148 and then give some delay of some 3000 milliseconds. So that is the program. Start the simulation. So distance is converted is measured in centimeters, and the use n so that it will print in new line. So distance in centimeters and distance in inches. Now you can change the distance of your object and then check the distance. So this is a simple program. So first thing is we have to initialize pin 3 as an output pin, right? And pin 2 as an input pin. So pin 2 is an input pin and 3 as an output pin. So echo we have to receive, and the trigger pulse it will be sent, right? And then so give some gap between the high and low state. So for 20 microsecond, then read the pulse input from 2. So from 2, you can read the echo, right? So read from the echo from pin 2, and then convert the microseconds. As I told you, for any measurement, we have to set trigger pin to high. So we have connected 3, and this should be connected to high for few milliseconds. And here I have used 20 milliseconds. And we have to wait until the echo pin goes high. Once it goes high, the length of the echo is proportional to distance of the object, right? So to convert echo pulse length, which is in the microsecond, to centimeters or inches, the centimeters divide the pulse in microsecond with 58. To convert into inches, divide it with 148. So this is the ultrasonic distance sensor, which is used to measure the distance to an object using ultrasonic waves. So I hope you all understood. So if you want to change this distance, you can edit the distance. You will reduce the distance also. Right? It will show in centimeters as well as in inches. I hope you all understood.